In this video, I'll be discussing trait objects. Trait objects offer a way to dynamically change program behavior at runtime. First, let's go over some basics. Trait objects are dynamically allocated objects. You can think of trait objects as generics, whose types are calculated when your program runs, instead of when you compile your program. Determining this information at runtime is called dynamic dispatch. Contrast this to generics, which determine the type at compile time using a process called static dispatch. One major benefit of using trait objects is mixed type collections. Normally, collections require that each item be the same type, but with trait objects, each one can have a different type and exist in the same collection. This makes it easy to work with data that has similar purposes. For example, we can place employees, managers, and supervisors into a single vector. Using trait objects in this way enables polymorphic program behavior. Since we can have a vector with multiple different types, we can create a program that behaves differently for each type in the vector. Trait objects also work well with rapidly evolving program requirements. If we create a new structure, we can turn it into a trait object and just use it with our other trait objects. Building on the previous example, we could add a contractor as a trait object and bundle it with employees, managers, and supervisors, and then perform some actions with all of them. These benefits do come with a drawback though. Dynamic dispatch has a small performance penalty in terms of speed and memory usage. So we're going to create a trait object. Before we do so, we need to first make a trait. So here we have a trait. It's named clicky and has a single function named click. Next, we have a keyboard structure, and then we're going to implement the clicky trait for the keyboard. And when the keyboard calls the click function, we just print out click clack. Creating a trait object is fairly straightforward, and there's multiple ways it can be done. On this first line here, we're creating a new keyboard and just naming it Keeb. On the second line, we're creating our trait object. To create trait objects, we're going to make heavy use of type annotations as seen here. Remember that type annotations require a variable name followed by the colon and then whatever type you wish it to be. Recall that trait objects use dynamic dispatch. So for our type annotation, we're going to use dyn, which is short for dynamic. We're going to pronounce this din. So we're going to use a reference to din clicky. Clicky was our trait. We're just going to set it equal to a reference to our variable. You can also think of this as just borrowing the variable. So this will be the first way you can create a trait object. The second way to create a trait object is to just immediately borrow a structure that you created. So here we're creating a keyboard, we're immediately borrowing it, and we're setting the type annotation to be a reference to a din clicky. Usually you don't really want to use this too much. You want to stick with the first one or the third one, which we're about to go over. The reason you don't want to use this all the time is because storing a reference into a vector isn't always useful depending on what you're trying to accomplish. Now for the third way of creating a trait object, we can put it into a box. So when we put something into a box, it lets us move things around. So far, we've been borrowing everything. So we have borrows here, here, and here. And those become problematic when you try to use them in different scenarios. However, if you put it in a box, you can move it around wherever you want. So if we set the type annotation to a box and then set the data inside to a din clicky, see that there's no borrow here, so no borrow. Then we just create a new box using box new, and then put our new keyboard into the box. So we're going to create a new keyboard structure. It's going to go into the box, and then now we'll have a keeb that is a trait object because we're using the din keyword, and it's in a box, so we can move it around to different functions or store it in vectors. Now that we know how to make trait objects, let's see how to utilize them with functions. So here we have a function named borrow clicky. So we're going to be borrowing a trait object for this function. The function parameter is just named obj for object, and it accepts a trait object, as we can see from the din keyword, and it's just borrowing it, and it's going to be the clicky trait that we created earlier. Within the function body, we're going to take that object and just call the click function. We know that the object has a click function because the function parameters specify that this trait object must implement the clicky trait. So if you try to use it without using a structure that implemented the clicky trait, it'll just fail to compile and you'll get an error. There's actually another way to create trait objects, and that is to not even include any type annotations. Now, I know that may seem weird at first, but we do have type annotations here up in the function parameters. So as long as you have the type annotation somewhere in your program, then Rust will automatically convert it into a trait object when you try to use it. So here we just create a keyboard, assign it to the key variable. We then borrow the keyboard in our borrow clicky function. Since the borrow clicky function takes a din clicky type or a trait object, we know that Rust will automatically convert it, and then we'll get the click function called. So this is, in general, the way you would want to use trait objects. That way you don't need to annotate every single one as a trait object. You just annotate the target of the trait object or whatever's using it, or the collection. You annotate that with the din trait, and then everything going into this function here, the borrow clicky function, everything coming in to this object will become a din clicky object. The same thing applies with boxes. So we don't need any type annotations here because we have the type annotation here in the target function. So we can just make a new keyboard, stick it into a box. Now we have a box keyb. We then move this keyb into this function, which then comes up here into object. So object is some kind of box. We know that we want to use dynamic dispatch, so we have the din keyword and the clicky trait. So we have a dynamic clicky object. Once that box comes in, we'll call the click function and we'll get the desired functionality. So remember, if you want to move trait objects, you'll put them in boxes. And if you want to borrow trait objects, you can just borrow them directly. You don't need to put them in a box. Now we're going to look at how to create a heterogeneous vector. That is, a vector that contains multiple different types instead of just the standard one type per vector. So we're going to add another structure here. We're adding a mouse structure. We're implementing the clicky trait for the mouse. And all the click function does is just print out click. So we have a keyboard that click clacks and a mouse that just clicks. Now we have two separate ways to create trait objects. So we have our keyb and our mouse here. So we can annotate each one with what we need. So we're going to use boxes. So we have a box din clicky, box din clicky for both the keyb and the mouse. And both are being placed inside a box. We then have a new vector being created with the vec macro. And we have the keyb and the mouse in the same vector. We're just naming it clickers. So this is one way to do it. So you either annotate each variables themselves, or on the second example, you can annotate the vector, and then anything that's boxed will attempt to be turned into a dynamic clicky trait object. So we see down here, we create our boxes just like we did before. We don't have any annotations. We then have our clickers vector, and we're annotating the vector itself. So we have a vector that contains a box that contains a dynamic trait object of the clicky type. We then have our equals, and we just make a new vec and then pop in the keyb and the mouse. You'll prefer to do the second method because if you end up having lots of different objects you want to put into the vector, it's much easier just to say, make all these things into dynamic objects instead of having to do each one at a time with type annotations. Now that we have our vector created, we can utilize it using a function. So here at the top, we have a make clicks function that takes a clickies, which is a vector containing a box containing a dynamic clicky trait object. So what we can do is we can add a keyb and a mouse. They're being boxed up. We can put them into a vector using the vec macro with our keyb and mouse. So our vector here has two separate things. It has a keyboard and it has a mouse. We then call the makeClicks function with the vector. It's going to go up here. And now we can iterate through it. So we have 4 clicker in clickies. And then we're going to call the click function on each trait object. So when this prints out, we're going to get click, clack, and then click. So the click, clack will be for the keyboard, and then the click will be for the mouse. So this situation here is probably the most common use case for trait objects, just placing them all into a vector and then iterating through each one and performing some action that will be different for each one. Using trait objects in this way makes it pretty simple to have lots of different functionality for lots of different things. To recap, trait objects allow for composite collections. They are slightly less performant than using generics, and that's because they get calculated at runtime instead of at compile time. You use the din keyword when working with trait objects. If you forget the din keyword, you'll get a warning, but that's going to become a hard error in a future Rust version. Trait objects can be borrowed using a reference, or they can be moved using a box. Usually, you'll want to use a box when you store objects in a vector. Otherwise, you'll start running into multiple errors, and it usually just makes more sense to store boxes in a vector. That way the vector can own all the data.